Hello everyone, welcome to my YouTube channel, and the question for today is minimum operations to make array equal. Alright, so given an array of length n where every element is calculated by this formula where I is the index of the number and for all valid I because I ranges from 0 to n less than n. Alright, so in one operation we can select two indices x and y such that x is the both are greater than 0 and less than n, so they lie between this range, and we can add and subtract 1 from x and add 1 to y. Alright, so we can perform this one operation, and because if we select two elements and we do this, so it's called as one operation. Alright, so the goal is to make all the elements of the array equal, and it is guaranteed that it can be made equal using some operations. Alright, so we have to make all the elements of array equal by using these operations. Like we have to select two indices and we have to add and subtract at the same time, and that will be called as one operation. So we have to basically return the minimum number of operations that are needed to make all the elements of the array equal. I hope the question is clear to everyone and the problem statement as well. It's a bit of a mathematical problem. Let's see how we are going to solve it. Alright, there's one example given over here, and I say as n is 3, so the first index would be calculated as 2 into 0 plus 1, that is 1. The second will look at 2 into 1 plus 1, so it would be 2 into 1 2, 2 plus 1 3, so 3, and similarly 2 into 2 4 plus 1 5. Alright, so that's how this array is calculated using this formula, and we have to make them equal. So the number of operations are 2, because if we add if we add here 1 1, so it would be add here and subtract here, it would run 2 3 4, and again on adding and subtracting it will run 3 3 3. Alright, so the number of operations returned here is 2. Similarly for 9. Alright, so now let's see, it's a bit of a hodgepodge, and now let's see how we are going to solve this problem. Alright, so alright, let's see, here is an example given over here. Alright, it's a 0 index 1 2 3 4 and 5. Alright, so yeah, I hope it's clear, and yeah, so this is the example given to us over here. Alright, so now let's see how we're going to solve it. So basically what the idea for this approach would be, we have to make this equal to this. Alright, if we make this equal to this, then only our array will be equal. Alright, and what we are going to do over here is, suppose here we subtract we add 1 and we subtract 1, so it becomes 6 6. Alright, here to make it 6, what we do is we add 3 and subtract 3, so 3 operations, they both will make total 3 operations, they both will make a total 1 operation, because 3 times 1 1 1 is added and 3 times 1 1 1 is subtracted from this position. And similarly for this 5. Alright, 5 operations, so 1 plus 5 6, and 11 minus 6, that is 11 minus 5, that is 6. Alright, so I hope a little bit of approach is clear. Let's see how we are going to solve it. Alright, so we see that basically we need to find the middle and we need to make both the equal. Alright, so if there is no number, suppose their length is even, so there would be another approach, and for odd it will be another. Let's see for the even first. Alright, so for the even over here, that is, let's say the plus 1 plus minus 1, basically minus 3 plus 3 plus 5 and minus 5. So if we take these operations, and we can see that it is basically nothing but an AP series with a difference of 2. Alright, so for an AP series with the difference 2, what the sum of the AP series is, Sn equals to n by 2 into 2a plus n minus 1 into d. Alright, so the first element over here is 1 only, so it would be 1, and the difference here is 2. So let's fill in the values and see what formulas come. Alright, so it would be n into 2 plus n minus 1 into 2 by 2. Alright, it becomes n into 2 plus 2n minus 2 by 2, so 2 to cut, so 2n into n is 2n square by 2, that is n square. Alright, so the n square comes out the formula for this sum where the difference is 2 and the first term is 1. Alright, but as we can see in this question that we are not calculating the entire sum of n numbers, we are just calculating the sum of n by 2 numbers. So on replacing n by n with n by 2, the formula turns out to be n square by 4 for even. I hope it's clear how we are reaching this point, because we can see that if we sum all these numbers, it will give us the total number of operations that will be our answer. Alright, because adding this and adding this becomes one operation. Had it been different, so we have to take the entire sum, so we are taking the half sum in this case. Alright, I hope it's clear why we are taking the half sum, and I hope this formula is also clear. It's nothing but a mathematical formula for the sum of first n numbers of an AP series where the difference is 2 and the first term is 1. Alright, yeah, I hope the calculation is clear as well. Alright, so for even, the formula is n square by 4. Alright, now let's see for the odd what we're going to do. For odd, what we can say is there is just a decrement of one number and the formula turns out to be same, n square minus 1 by 4. Alright, now let's think for a second, taking any number value of n. Suppose we say 5, n is 5. Alright, so 5 into 5 by 4. Alright, and 5 into 5 by 4 minus 1. Alright, because sorry, for any value, not for any value of n. Suppose the n equals to 6, that is even, so 6 into 6 by 4 would be answer for even, and n equals to 5 would be 5 into 5 by 4 minus 1. Alright, so why we are subtracting 1? But just to make this an even number so that it could be divisible by 4. So instead what we can do over here is, the formula for that is n square by 4 even. Alright, but for odd it is n square minus 1 by 4. Alright, why minus 1? Minus 1 is just to make it a whole value. If we just an even number, that is 5 into 5, 25, and we divide it by 4, we get a whole value. Similarly, if 6 into 6, that is 36 by 4, that is 9, and it would just give us 25 by 4, it would just give us 7 point something, 8 point something. Alright, so 8 point something would be the answer. So in integer we take the floor only, so we take 8 only. So yeah, we don't need to subtract because this formula can work for both odd and even. That was my purpose to understanding why we are using why we are driving the same formula for both odd and even. Alright, because for the even we know what is it, and the for odd, why there is minus 1, there the minus 1 is just because the number of are odd. Alright, and it just reduces it to a number that would be subtracted by, that would be divisible by the lower bound number. Alright, if 25 minus 1 was there, then it would be easily divided, but 25 by 4 is 8 point something, but the int in our any language will take the floor value. If nothing, you can use math.floor as well, but int will automatically turn it into number, so we will using the same formula. I hope the approach is clear. Let's see the code. Alright, and the code would be very much simpler, I'm telling. So yeah, here is the code, only one line. I know it's a bit surprising, but yeah, we have driven the same formula. It's same formula both and odd and even. And yes, let's try to submit it. I know you are not believing me that we can use the same formula, but because the integer operation is nothing but a floor also, because so that's why we can use this formula for both odd and even. And see, it's accepted, I told you. So yeah, I hope this question is clear, and how we have derived the formula and everything is clear. And it would just time complexity would be for this question would be over 1 only, because we are not traversing or anything, and the space complexity would be same as well. All right, so constant time and space complexity would be there, and I hope it's clear. If you still have any doubt regarding this, you can ask me in the comment section, and please like this video, share it among your friends, and subscribe to my YouTube channel. Thank you for watching. Bye bye.